Okay, greetings everyone. So today I wanted to go over vectors and then also uh, how we would make our own vector class because there are some shortcomings to the vector class that is provided to us by C++, and we should know enough to be able to write our own that maybe has features that make more sense to us versus the official vector, the standard vector class, which how did Rod put it? That a lot of the decisions of the structure was probably made by committee, where sort of everyone lost the battle, where a lot of people proposed good things, and then they debated it, and no one could agree, and so they ended up compromising with something that nobody quite liked. So this is an opportunity for us to write our own that does what we want it to do. And then we would check in on the forum posts, and then I'll look at the practice midterm if any of you have any questions on any of them. So the nice thing about vectors was that they solve a lot of our struggles with partially filled arrays, that we don't necessarily need to care how big a vector is. We can just keep putting stuff into it, and it's totally fine. So that's the issue with an array. Is an array it's a certain size, and you can't easily change that size. Essentially, there's a trick where you make another array, and then you that's bigger, and then you copy everything over, which is actually what the vector class does in the background. You just don't see that. So the vector class is doing all of this work for us already. Also, it knows how big it is. That you can just ask it what its size is, and it will tell you how many things are in it. For a partially filled array, you have to not only keep track of how many elements in it are valid, but you also have to keep track of how big, what is the maximum capacity of it, and that after that point, you make the decision of either you can't take any more stuff, or you have to make an entirely new array. And so vectors solves all of those kinds of problems that we had with partially filled arrays. Also, if we use the @ keyword with a vector, we're not going to get garbage. Where in an array, if you use the square brace to access an element that's into the garbage area, you're going to get garbage, and you may not know that you're getting garbage. You're just inheriting whatever was left over by the previous program. So this is an example from the C++ reference for the vector class using the @ notation. So the @ notation is much safer. So let me just go through this. So IOStream, this allows us to take in and print out stuff. The vector class, that's our vector. Using namespace essentially makes it so that we don't have to say std : all over the place. So we make a vector called myVector of type integer, and then we have an integer called myInt, and then we ask the user to type in some stuff, and then 0 to exit. So we do so 0 is false. So essentially what happens is that if they type in 0, this while expression becomes false. And we don't initialize myInt because the first thing we do is we look at the value we change the value before we look at it. So if it was the case that it was a while loop instead of a do while loop, you would have to initialize this myInt to something, because otherwise the first thing you do is some garbage that was left over by the previous program, and that loop may or may not run. So you would have to set this equal to some valid thing. So you'd say myInt equals 1, and then that would allow this to be 1 is true. But in this case, we're just going to do while because we're taking input from the user. We take in the input, we store it in myInt, and then we push it back into the vector. So if they typed in a 0, we would put the 0 in the vector. It would be in the back of the vector. So if we didn't want it, then we could keep this same code here, and then we could just pop it off if we really wanted to. And then here, this is how we get the size. We're able to say myVector.size. And this is known as casting. Actually, this is converting. I don't know why that's like that. That int should not be there. So the myVector.size is going to return an integer, and it's going to print it out. So we can get rid of this int part. And then, so this is from the C++ reference. So I'll have to modify this even more. And then we print out my vector contains. We don't print out a new line because then we print out each of the elements. And we're using the add because it's much safer. Because if something's wrong, this is going to tell us that something was wrong. If we use the square bracket, it's not going to tell us. So yeah, so this is using that notation. It's pretty much the exact same, except instead of the square brackets, we use the dot add and then out the index. And this is much safer because the errors that you're going to get are going to be very informative versus when your program uses the square brackets, your program might not even crash. It might keep running and start doing weird things, and you don't want that to be the case. You would much prefer your program crashes because you did something wrong than then if it keeps running if it did something wrong, because maybe you might not notice it immediately or not. So yeah, so essentially we can make our own vector class. So we know how to make classes, so we can call it my vector class or whatever you want to name it. And let's just say that it's going to be of type integer. We're not going to make it generalized like the normal vector class. And that, yeah, so it's going to have an array of integers. And when we put an element into it, it's just going to essentially change the variable size. So max size is the capacity. That's essentially how big the actual array is. But size is when you ask it how big it is, what it actually reports. So so the user may not have, or shouldn't have access to max size. Only your vector class will. And then empty would be, so let me just start at the beginning. So with begin, so it has the member function or method, begin, so that would give us the first index, the first element in it that's valid. End would give us whatever's at size -1. So if there's one element in it, then size is going to be 1, and then 1 minus 1 is 0. So at index 0, we would get end, which would also be beginning because there's only one element. Size would be the number of elements, and then max size is going to be the capacity, and that's how big the array is that you made. And then empty returns Boolean whether or not size is 0 or not. So if size is 0, then empty is true. Otherwise, it's going to be false. And so for this, you can literally just say return not size, and then you're done with your empty. So that's the activity for today. Yeah, let me know how you did. Okay, assuming you had a go and you did something. Yeah, feel free to, if you were having any troubles with this, just let me know. You can send me an email. My email is right there, cs11@carterfrost.com. So that's cs11@carterfrost.com. If you have any questions, or you can just ask me in class or whatnot. Okay, and then let's check in on the forum posts and the practice midterm. So all of you should have made your posts already of the topics that you chose. So this would be an opportunity for anyone online. Let's see, is there no one's online? So anyone that would be online could ask questions. But yeah, feel free to use that same email if you have any questions about whether or not you think that you got your answers that you generated, or if you had a hard time generating some questions. And then also we would check the practice midterm for, yeah, 2. So there are multiple versions. I think there are 3 different versions of this practice midterm. So yeah, so if anyone had any trouble with this practice midterm, it would be a good opportunity to ask, because we're going to be doing it in a few hours in class. So yeah, let me know.